Hello viewers, my name's Alan and welcome to my home workshop. Today's project is to install a compressed air outlet on the somewhere on my milling machine, so it's convenient to have a dust off gun and so on. So the system that I have used throughout the workshop, and which I'll be extending today, uses this push connector system. It's a quarter what's that thread called? Can't remember. A 1/4 inch something or other. Anyway, and there's an O-ring and a clamp, little push operated clamp. So you use a nylon tube. This one's 3/8 of an inch diameter, and you just push it in. It's as simple as that. To release it, you pull that down and it just comes out. So it's a highly suitable system for a permanent air distribution system, but one that's easily changed. So we'll be using line and one of these. I want to have a couple of quick release connectors. These are the Nitto style. Get in there. All right, and so I want to get a couple of those. And because I've got 2 or 3 things, I need some sort of a manifold. This was a cheap item bought from one of the big box hardware stores, and I've got to find out what that thread's called. It's annoying me, I can't remember. Just hold on a second. Alright, so I've looked it up and reminded myself. BSP, of course, 1/4 inch BSP. Anyway, so I need a manifold, and because I've got quite an extensive distribution system, it's not been possible to run the piping in the ideal configuration, and so at every outlet I basically have one of these as a moisture trap to deal with that. So the plan is to basically put that there, this on the side of that, so I'll have compressed air supply coming in there, connect to that, a couple of these, fill up the blank holes with blanking plugs, and that should be that. Sounds easy. So let's go and have a look at the machine and see how we can actually mount these components. Alright, well, I've decided the best place to have the air blow off gun is somewhere like this. I'll make a special hook for it later, but there means it's convenient but out of the way. So to get air available to that, I'm going to come around and look at my options on the back here, and I think the best position is going to be over on the other side, so I don't get in a tangle with the maker's plates or anything like that. Go around the other side. So I'm thinking here is the go. This is tucked away, so I can get at it, but they're not sticking out for me to catch myself on. This is the adjusting knob for setting the limiting the pressure through the thing, so I can get at that. This is protected, and I'll be able to bring the air hose down into here. So all I have to do now is work out how to actually fix it to the column of the machine. Okay, well, I've had a bit of a head scratch, and now I've pulled all the splinters out of my fingers. I've decided what I'm going to do. My first thought was to fix this directly to the machine with long screws through these holes. This filter regulator did in fact come with such screws, but I realised that even if I did that and firmly mounted this, there wasn't going to be anything to stop this from turning if the hose pipe pulled on it or yanked on it. So now I'm thinking that the best option would in fact be to fix this and hang everything else off it. Of course, this hasn't got any mounting ears, which is an annoyance, but what I'm going to do is I've got this piece of aluminium plate here, and I'll make a piece of it to go something like that, and it's just thick enough that there's a little bit of wiggle room here, so this device can be put on without actually being wedged against the machine. And I think the best way to fix this manifold to the plate is with a couple of screws coming in from the back, and then with the thread sealed. What we can see looking at this thing is that this isn't actually square, and what I'm going to call the top face and the bottom face are actually thicker than the sides. But if that's put on there, I can drill right through, screw from the back, thread sealer, and I think that should do the job nicely. And I'll leave enough of a margin top and bottom to put 4 mounting screws through, and then that'll be a solid base to attach that to, and the other pieces. So that's what I've decided to do. Okay, so let's work out some sizes, and we're going to do some drilling. So I want a plate that's going to be basically a rectangle, and we're going to set the manifold block on there. There's 3 holes, and we want to have 4 mounting holes. To minimise the setup in the milling, or when I go to drill the holes, we'll put all those holes on the same centres, and obviously same that way. So what about some dimensions? Right, well, this block is 19, close enough. These dimensions are not going to be critical, and the heads of these screws 8.5. So if we allow 12 each side, it's going to be ample room for the screw heads. And this block needs to be the length of the manifold, but it doesn't actually matter if it's a bit longer. That's 95. Plus or minus. Certainly isn't a critical dimension, and I think it's not going to do any harm at all if it's slightly long, so I'll not bother to shorten it. So these holes here for an M5 screw, and to locate them from a corner, we're going to have them in the centre line of that. So to work out the distance between centres for the 2 screws that are going to fix the manifold, I'll just measure across there. That's 72.7, close enough. 2.7, and then we've got to subtract 12.9. And we're going to get 69.6. That would be good enough. And that hole pattern of 69.6 will just need to be centred on the length of the mounting plate. So we can do all that with the DRO. And the spacing in from the sides for these holes here is going to be, well, this piece is 12, so we'll go 6 there, halfway in, which will be 6 there, then we've got 19, another 6 and another 6. So that's all we need for doing the setup on the DRO. We'll call this our origin, and off we go. Well, but first we have to cut this to size. Probably a good idea to do a bit of marking out first though. So we're going to have to square the plate up, and about there somewhere probably. So let's have a look here. don't need to make another cut, but we will clean that up in the milling machine. And then we want to be 43 in from there. That'll be close enough. Yep. And we'll do the rest of the positioning with the DRO once we've got the block in the vise. So next move is to the hacksaw, chop it off. Now, because this bandsaw is pretty cheap, and I'm not sure how accurately it will cut, I'll give it a bit of a margin and we'll see how we go. Well, it's not too bad. It's actually cut pretty square. I don't know how well that's going to show up, but that's alright. Happy with that. Okay, what we're going to do here is set this piece of aluminium up in the vise. The idea is to have it set a little bit high, tap it down, till we're aligned. So I've just got a parallel here, so I can see against that line. We'll start tapping it down. That's looking good. Perhaps a touch more just at this end. I'll lock that in. Okay, now I need to put in change the tool holder for a milling cutter. Alright, to make the tool change I'll use my Franken hammer, as I call it. So that's socket at one end, hammer on the other. Works pretty well. So right size for up there, and hammer to loosen that. There we go. I'll swap this. Let's go with this one. So I'll swap this for the collet holder. Frankenhammer again. There. Alright, let's get an end mill in there. Sorry about that, ran out of battery in the camera. Back down to 0, and we'll take perhaps 1/2 millimetre just to give ourselves a start. Now we're in high gear, yeah. And I think we'll take these two pieces out of the way before going further. Well, pretty happy with the finish that cutter leaves. Okay, I think if we come down a millimetre, that'll be good enough for our purposes here. Okay, so we'll flip it over and clean the other side up. So in cleaning up the other side, I want the piece to finish up 43mm wide. And the way I'm going to do that, I have the piece standing on a parallel to keep it up out of above the cut line above the top of the jaws. I'll move this in and bring the cutter down onto the parallel, which is marking the bottom of the piece. Zero my quill DRO, and then come up 43. We should come out pretty close. So we'll go in. Get everything clamped up. Tap him down. Tighten it up. We should be good to go. Let's put a squirt of WD-40, or the one I use, which is not actually that product, but same sort of thing. Okay. Okay, now we'll take it out and check it and see how close we got. Well, I'd say that's close enough for this exercise. Let's check the other end. Well, happy enough with that. Okay, I thought about how I was going to drill this hole pattern, and I changed my mind about where I'm going to set my datum for doing measurements with a DRO. So that's the back plate and the manifold block that's going to sit on top with its 3 holes. And I want 4 holes like that, and then 2 more there and there. All of these holes, these 3 are going to be on the same line. Those holes will be on the same line, and those are on the centre line through the block, and these are on the same line or the same offset. Messed that up, but never mind, you get the picture. So what I know, if I choose this as the start point, the offset of these 2 holes from that line is half of the manifold is 19 wide, so half of that's 9.5, and then I want 6 there, so that means the offset there is 15.5. Same on this side, 15.5. Similarly, working out the offset from the centre, I know that the hole spacing of these 2 has to be 69.6. So divide that by 2, 34.8. So the offset here is 34.8 and 34.8 here. So with those offsets from the centre, it makes it easy to locate those 4 holes. And these 2 are on the same offset, 34.8, but actually on that centre line. So the 4 holes there on the outside are going to be 6mm, clearance for a 6mm screw. And I guess the same for the centre 2, 6mm screws again. So let's get to it. Okay, so I have the mounting block set in the vise on parallels, the manifold block sitting on top, and I've located it just by feel from the ends because that's not critical, and I'll easily be within 0.5 millimetre there, probably 1/4 millimetre. Its location off the centre line, I've got 2 gauge block stacks here, 12mm gauge block stacks. So there's my 12, 12 and the 19, making up the 43. Anyway, so that's got this on the centre, and so now all I have to do is, using the wobbler, locate the centre of this block. So I'll do the each end, halve it to get it that way, and same across that way. Then I'm on the centre there. Then I can do my measurements for drilling the holes straight off using the DRO. Right, that end's tipped, so we set X to 0, there the other end. Back again till tipped. So now we set X to divide by 2, and now when we go back to excuse me, back to 0, and on the y-axis we now know the spindle is right over the centre line of the part. So we can do drill our whole pattern from here using the offsets that we've calculated. Okay, we'll start with the 2 holes on the centre line. They need to be drilled 5mm because that's the correct tapping size for a 6mm screw. So we'll drill those through at 5, and then when I've done that, I'll be able to take the manifold block off, and without releasing the backing block, drill through to open up the holes in the backing block out to 6. Now, to set the offset for these two, we stay on the centre line, so Y stays at 0, and we've got to take X to 34.8 in each direction. Ready for our first hole. Well, that's not right. Something's gone wrong there. Back to the drawing board. Okay, well, I've been back through my numbers and found out where my error was. Basically, I need to go back and repeat grade 5 maths probably, because 72.7 minus 12.9 is not 69.6, it's 59.8. And when you divide that by 2, you get 29.9. So that's what we should be using. I've reset the x-axis reading to 29.9, and now, funnily enough, the drill's in the right place. So there we go. We live and learn, make mistakes, recover, etc. So time to drill a hole. Now this is a small hole through aluminium, so I think we can wind the speed up quite a bit. Something like that's probably good. First 5mm hole, and then we come back this way, 29.9 on the other side. Swarf off there. Might even give it a bit of a squirt of that. Right. And that drills in the middle of that hole as well, that's comforting. So that's our 2 5mm holes, which will be opened out to 6 in the base block when we remove this. So 5mm drill out, 6mm drill in, get my gauge blocks out of the way so they don't get damaged. And we still want to go with X on 29.9, but now we've got to offset on the Y by 15.5. Like that. Yes, that looks like it's in about the right place. I've just remembered that the parallel under that side would get in the way if I kept going. So I think I have to wait to drill those until after I've pulled this off. Which I suppose I could do now anyway. Okay. Yep. Right. Now we'll take these away from the edge and we can go drill through. Now we can open these holes out to 6 because they only need to be at the tapping size in the block. So we come back into 0. And open this out to 6. Yeah, I've got to have to do a counter bore here for the head of the 6mm screw. Well, I think I'll drill the other hole out to 6 first. Get set up with a counter bore. No, it's really coming down to 6 here as well. Yep. can take that out now and tap the holes in the manifold block. Bit of deburring as well. Okay, I didn't bother showing running a tap through those holes. I think there's enough videos of how to tap a hole on the internet without me showing another one. So those are the counter bores and my little screws. With the final assembly, I'll be using a sealing compound for these. That's basically finished making the block. So I've just remembered or realised a detail. When these plugs get screwed in, they typically don't go even flush, let alone below the surface. And for the plug that I need to put into the back of this manifold, it needs to be below the surface. So what I'm going to have to do is machine a relief that's underneath where this middle hole will be. So back to the milling machine. Okay, so put the assembly back in the vise. Now I have to find this hole again, and I'm going to do it for the accuracy I need. It would be good enough to use this as a guide, so that's a reasonable fit in there. Let's slip this in the chuck. Then find that. And that'll be close enough for this. So with the centre found, I have to change this back to a milling collet and use the nearest slot drill I've got to put a recess into the base here. Alright, I've set the quill DRO to 0, and I think if I go in, say 4mm arbitrarily, that'll be heaps. So we'll start the mill up. There's our 4mm. Alright, so that's got that done nicely, plenty of clearance there. And we'll be able to reassemble that without any trouble. Leave the screws a bit loose. Yeah, that's all good. Plenty of clearance all around there. So ready again to locate it on the back of the column and start drilling some holes to mount it. Alright, I think just about there will be fine. So let's mark one of the holes, get it drilled, and then mount the plate and mark the other holes. Let's get this first hole marked and drilled. So drilling in this sort of situation, I always prefer to use the air drill because it's very high speed. So a drill that wasn't blunt would help. check the depth on that. Well, that should be deep enough. 14, 15 millimeters. We'll take what we can get with that. Now that drill was slightly undersized, so we'll go in with the 5mm drill now. Right. Right. So that to get us started. Now, go in a bit further. Going with the bottoming tap, plug tap. Make sure it's threaded to the bottom. Right, so, okay, so we just blow that hole out. Alright, make sure that's okay. Doesn't look like I'm very square. Not too bad that way, but not too bad. That screw's slightly long. I have to shorten that. But anyway, it's going to get the job done for us. Alright, let's get a spirit level. Well, that wasn't a bad guess, was it? Nip him up at that. Okay. Yeah, just have to spot through the other holes. Now, to make drilling the other 3 holes a bit easier, and also because it's important that they be in the right place and at the right angle to the face, the bolt face, I'm going to use these little bushes they were made ages ago for some other reason. They've got a 6mm outside diameter, and they're just right for this number 30, I think. Just a drill that's slightly over an eighth. Over an eighth. Let's push those. Oh, one of them doesn't want to go in. That's obviously a pretty good fit. Right, let's get this hole. We'll take it off, take it off and retrieve the bushes. Clean the hole out. I guess that's deep enough. Right, get the tap started. I'll do. I'll finish that by to knock those little bushes out. All right. All right, well, let's make sure it fits. Yeah, well, that seems to be all right. I'm not actually sure whether it needs the other two screws. In fact, I'd be pretty sure it doesn't. So the question is whether or not to do them anyway, just because I've done the holes. All right, ready for a test fit. Make sure it's all going to go together before I start putting sealing goop into things. Right, a little bit of wiggle room there. Yeah, I think that's going to be just fine. Okay, so it's all assembled and gooped up. I use this product, Lock Seal, for all of the BSP joins, quarter BSP joints, except for the tail here, which is just temporary, so I've just used PTFE tape there. The screws here, which have to be sealed into the back of the manifold, I sealed those using Loctite 263. I've never tried using Loctite as a leak sealer. We'll see if it works. Now, because there are so many holes, I thought it'd be worthwhile doing a leak test. So let's see. Well, it looks like I have one leak. And it's where the temporary connection is for the hose, so I'm really not worried about that. But it looks like all of the other joints are airtight. Oh, maybe did see one more air bubble from the lower of the two screws holding the manifold block on, but it could have been an air bubble that was trapped in the countersunk head of the screw. I'm certainly not seeing any other leaks now. Let's turn it over, see if that makes any difference. So I'm pretty happy with that. As far as I can see, the only leak I'm getting is from the temporary connection, which I don't care about. But it certainly doesn't seem to be leaking from any of the other fixtures into the manifold, so that's good, including the two fixing screws, which is where I thought I would get a leak if I was going to get one at all. But happy with that. And by the way, that leak is the reason I choose not to use PTFE tape whenever I can. This leak seal just is the dog's what's-it, so I've never had any issues with that. Just a small bead around it, plenty of time to work with it, and it actually sets as well, so leaves you free to position things as you want them to be. And oh, we get one more, right, there we go. And as I say, it will set, and that will then hold its position. So we'll leave that, let the stuff actually start setting off very quickly, like within a few minutes really, but full strength, the usual story, after a few hours. So I think I will let that go overnight. Actually, I probably should have waited overnight before leak testing the whole lot anyway, because the I don't know how long the Loctite was going to take to get full strength. Anyway, we'll leave it for now. Okay, well, it's next day now, so the sealing gets all dried. It's time to do the final assembly. And I've decided to use a small O-ring on the back of each of the screws between the mounting block and the column, just to take up any irregularity and unevenness in this face, because it isn't a machined face. So with the screw, put one O-ring on like that, drop it on the floor, etc. Alright, I went down a size of O-ring, and it has the advantage of holding the screws captive until I can get them in. I won't drop them so often. So we start off with the one long one. Right, just got them all started. Right, I think that'll be fine. And it's time to put the connecting hose on. I'm thinking that I'll put an angle there to make it a better exit up to because the line's going to come down from above. And that's it for now. So I'm waiting for a T-piece to come in to make the connection at the other end of this this input line. Well, thanks for watching the video, and I hope you found it interesting.